Hi student, this is Kumar. 11th standard mathematics chapter number 3, continuation of exercise 3.9. Now problem number 11. Derive projection formula from law of sines and law of cosines. Here is question number 11. First we can write the projection formula. Projection formulae in triangle ABC. The first one is A that is equal to B cos C plus C cos B, and second one B that is equal to A cos C plus C cos A, and third one small c that is equal to A cos B plus B cos A. So we can prove these formulae by using the sine formula. Now subdivision 1 using sine formulae. We know that A that is equal to 2r sine A that is equal to 2r sine A, that is equal to, in triangle ABC, A plus B plus C that is equal to 180 degree. Therefore, A equals pi minus of B plus C. Plus B plus C comes right hand side, minus of B plus C. So, 2r right as it is, sine of, this can be written as A can be replaced by pi minus of B plus C. That is equal to 2r into, now you can go for that ASTC concept. This is pi, is 180 degree. For 180, sine becomes sine, angle is B plus C. 180 minus lies in second quadrant, sine and cosecant positive, we have a sine, therefore it is positive only. That is equal to 2r into sine of B plus C. You can apply the formula. See, if I apply, you will be getting sine B cos C plus cos B sine C. Since sine of A plus B formula is sine A cos B plus cos A sine B, have applied this formula. That is equal to 2r into sine B cos C, 2r into sine B cos C plus 2r into cos B sine C equals 2r into sine B into cos C plus 2r into sine C into cos B. That is equal to 2r sine B according to the sine formula, this is B into cos C. 2r into sine C, that is C. So B into cos C, C into cos B. What is in the left hand side? A. So A that is equal to B cos C plus C cos B. Here it is. Formula number 1 is derived. Now formula number 2 for proving this result. First one is over. Next, we know that B that is equal to 2r sine B from sine formula. That is equal to, we know that in triangle ABC, A plus B plus C that is equal to 180 degree, which implies B that is equal to pi minus of A plus C. Plus A plus C comes right hand side, minus of A plus C. So 2 are right as it is. Sine, this B can be replaced by pi minus of A plus C. That is equal to 2r into, for 180 sine becomes sine, angle is A plus C. So that is the ASTC concept. ASTC. Here we have pi. Then 180 minus lies in second quadrant sine and cosecant positive. Here we have sine, therefore it is positive. That is equal to 2r into sine of A plus C. You can apply the formula sine of A plus B, that is sine A cos C plus cos A sine C. That is equal to 2r into sine A cos C plus 2r into cos A sine C. That is equal to 2r sine A into cos C plus 2r sine C into cos A. 2r sine A can be replaced by A from sine formula into cos C as it is. Now 2r into sine C can be replaced by sine formula small c into cos A. What is in the left hand side? B. This is the projection formula and number 2. B that is equal to A cos C plus C cos A. Now for proving the third formula of projection, consider small c that is equal to 2r into sine capital C from sine formula. Okay, that is equal to 2r in triangle ABC. Know that A plus B plus C that is equal to 180. We need capital C. So capital C that is equal to pi minus of A plus B. Sine of pi minus of A plus B. That is equal to 2r into, since we have the first angle is 180 degree, you can go for that ASTC concept. ASTC. Here we have pi. For 180 sine becomes sine, the angle is A plus B. For 180 minus lies in second quadrant sine and cosecant positive, we have sine here, therefore it is positive. So 2r into, now we can write the formula for sine of A plus B, that is sine A cos B plus cos A sine B. That is equal to, you have to multiply 2r sine A cos B plus 2r cos A sin B. 2r cos A sin B. That is equal to 2r sin A into cos B plus 2r sin B into cos A. That is equal to 2r sin A can be replaced by the formula A from sine formula, like the 2r sin B that is equal to small b. And cos B and cos A write as it is, cos B and cos A. So what is in the left hand side? C. This is the third projection formula. C that is equal to A cos B plus B cos A. Here it is. So I proved all the three projection formulae by using the sine formula. Right? Now using that cosine formula, I am going to derive that projection formula. Look at that. Now using cosine formula, we have that formula for cos A, cos B and cos C. This is the formula. In this formula, I am retaining 2c in the denominator. Just I multiply b with the cos A. B cos A that is equal to b square plus c square minus a square divided by 2c. Here it is. The next, I am retaining 2b in the denominator. You just cross multiply c with the cos A. C cos A that is equal to b square plus c square minus a square divided by 2b. Like that, from this formula, I am finding that a cos b and C cos B. Same procedure to be followed for finding that A cos C and B cos C from the third formula. Here it is. So I have taken that equation 1, 2, 3, 4, 5 and 6. Now I am going to prove all the three projection formulae using these equations. Right? Now adding 4 and 6. Equation 4 and 6 to be added. Equation 4 plus 6 implies equation 4 left hand side C cos B. Here the left hand side is B cos C. C cos B plus B cos C. That is equal to, I have to add the right hand side. Okay, the right hand side, a denominator is 2a, here also 2a, right? A square plus C square minus B square divided by 2a plus A square plus B square minus C square divided by 2a. That is equal to, here common denominator 2a, since both the denominators are same, you just add the numerator. Add the numerators, A square plus C square minus B square plus A square plus B square minus C square. That is equal to, here minus B square plus B square both get cancelled. Even plus C square minus C square get cancelled. A square plus A square, that is equal to 2a square divided by 2a. 2a square divided by 2a. See, 2 get cancelled, 1a get cancelled, which implies what is in the left hand side? C cos B plus B cos C. So you can write, have written A in the right hand side. I am going to interchange these two. A, that is equal to C cos B plus B cos C. This is the first projection formula. Now for proving the second projection formula, I am going to add equation 2 and 5. Equation 2 plus equation 5. Equation 2, here it is C cos A. Equation 5, here it is A cos C. C cos A plus A cos C. C cos A plus A cos C. That is equal to C cos A, here B square plus C square minus A square divided by 2B. Plus equation 5, A square plus B square minus C square divided by 2B. Here we have the common denominators, so 2B by 2B, that is equal to since both the denominators are same, you have to add the numerators, that is B square plus C square minus A square, B square plus C square minus A square plus A square plus B square minus C square plus A square plus B square minus C square. That is equal to, here you can cancel minus A square and plus A square plus C square and minus C square both get cancelled. B square plus B square, that is equal to 2B square. 2B square divided by 2B. Then both 2 get cancelled. 1B get cancelled. So what is in the left hand side? We have C cos A plus A cos C. C cos A plus A cos C. So which implies, I am going to interchange LHS and RHS. B, that is equal to C cos A plus A cos. That is a second projection formula. Now I am going to prove the third projection formula. For that I am adding, I am going to add equation 1 and 3. Equation 1 plus equation 3. Right, equation 1, left hand side here it is b cos A, and equation 3 a cos b, b cos A plus a cos b. Now we have to add both the right hand sides. Right hand side b square plus c square minus a square divided by 2c. Plus, here 2c in the denominator. Look at that, a square plus c square minus b square. A square plus c square minus b square. Now both the denominators are same, write that 2c. Now add the numerators as it is, b square plus c square minus a square plus a square plus c square minus b square. Now here plus b square minus b square get cancelled, even minus a square plus a square get cancelled, that is equal to c square plus c square equal to c squared divided by 2c. 2 get cancelled, 1c get cancelled, that is equal to, so what is in the left hand side? B cos A plus A cos B, which implies you can write C that is equal to B cos A plus A cos B. This is the third projection formula. So I have proved all the three projection formulae using the cosine formula. So problem number 11, both the subdivisions and all completed. Then I will be taking that next exercise in the next video. Thank you, children.